Welcome back to another past paper solution. Same 2013 paper. I guess I let the first video be part 1 and this video be part 2. Anywho, so for this problem, it says that x is mapped onto the set of real values. Simply means x is a real number, some real number, and this says this is a constraint. It says that x is greater than or equal to 1, right? And it says a function a is mapped onto the set of real numbers, is defined as f of x equal to x squared minus x. Right, so I'm going to use, it says, the problem says that we have to show that f is 1 to 1. So show that the function is 1 to 1, which means each x value has a unique y value, one unique y value. So one x value has one unique y value, which could say it looks like this. So if this is your x and that's your y, then each x value here would have a unique y value, right? Anywho, so I'm going to use a graphical method to do this. So x squared minus x is the function, so let's just set it equal to 0. Then we have x minus 1 there equals 0. Just doing this to find the roots. So let's just sketch our curve based on this. The roots are x equals 0 and x equals 1, so that means the graph should cut through like this. Say 1 is there, so the graph would look something like this, right? So as it states here, x is greater than or equal to 1, so we are going to ignore the part of the graph that is to the left of 1 and just focus on the part that is at 1 and past 1 going to the right side. As it says here, greater than or equal to 1, right? And I'll be using what we call the horizontal line test. So basically, if you should draw horizontal lines through this side of the graph, it would only cut it once, right? And since it cut it once, that means for each x value, like along here, there is only one unique y value, right? So that shows that it's 1 to 1, and that's basically a simple proof. It's 7 marks. So as I said, you just consider the right side of here, and yeah, basically that's it. So I'll just continue and do part B. This is actually Unit 1 2013 question 2, and this is part A of question 2. I'm going to do B. So B says let f of x equal 3x plus 2 and g of x equal e to the 2x. So one says that we're supposed to find f inverse of x, and with f inverse of x there is a simple way to do that. Basically you say let f of x be y, so you would have y equal 3x plus 2, then you would interchange the variables. So instead of having y there, you would have x is equal to 3y plus 2. Then you just simply solve for y. So y would be equal to x minus 2 all divided by 3. Therefore, f inverse of x would simply be x minus 2 over 3. And then the other one says you to also find g inverse of x. Now it's the same principle. You would say y is equal to e to the 2x, then you just simply interchange, so x is equal to e to the 2y, then solve for y. So in order to do that, we would have to log both sides using the natural log. So ln x would be equal to ln e to the 2y. Therefore ln x is simply equal to 2y, and therefore y is equal to half ln x, or if we want to tidy that up, we can say that it's equal to ln root x, right? Just go with ln root x. So therefore g inverse of x would simply be equal to ln root x. Right, so that's part A. Well, not part A, that's part 1 of B. Well, actually, let's see. Part B of number 1 says to find fg of x. So let me just clear here. Find fg of x, that simply means you're going to, anywhere where you see x in f, you would plug g. So right, so that's 3. That, remember now, anywhere you see x, you plug g. G is e to the 2x, so you simply put e to the 2x there and right back here plus 2. So that's fg of x. Now this says to show that the next problem, that's part 2, says to show that f of g in fg inverse of x is equal to g inverse x f inverse x. Yeah. Oh boy. So prove that that is equal to g inverse of x of f inverse of x, simply just find the inverse of fg of x. So let's do that. So the inverse good. Same procedure, so you would let this be y, so you would have y is equal to 3e to the 2x plus 2, and x is equal to why did that happen just now? I don't know. X is equal to 3e to the 2y plus 2. Now you solve for y, so x minus 2 over 3 would be equal to e to the 2y. Now we log both sides, so that's ln x minus 2 over 3 is equal to ln e to the 2y. Therefore, and divide both sides by 2. That's simply half that. 2 cancels, so y is equal to half ln x minus 2 over 3, so that is fg inverse. So that's half ln x minus 2 over 3. Good. Now we are to show that and so now let's find g inverse x of f inverse x. So remember that we found f inverse of x before. That was simply x minus 2 over 3, and g inverse of x was equal to ln root x, or half ln x. Now, since we have the half here, so let's just use this one for g inverse of x. So we're supposed to prove that is equal to great. So we're supposed to prove that, and as you can see, it should be simple. For this side, the right side, that just means you plug f inverse of x into g inverse of x. So let's just do that here. So the right side simply equal to half ln, and remember, wherever you see x in g inverse of x, you would just put the value for, or put the expression, I should say, put the expression for f inverse of x. So since there's a x, or there should be a x right after the ln, we're going to replace that with x minus 2 over 3, right? And as you can see, since you can say since f dot g inverse of x is equal to half ln that, and let's just use an arrow there. So since this part is equal to half ln x minus 2 over 3, and this side is equal to half ln x minus 2 over 3, therefore this relationship okay, good. So we have proven that, so we can, I'm just going to finish question 2. Yeah, there are just 2 more problems, or should I leave them for our next video? Let me see how much time has passed. Alright, I'm just going to do them. Alright, so C says we're to solve the following. So this is the first one: 3x squared plus 4x, and these are inequalities. Good. Now for the quadratic inequalities, I like to solve them graphically. So yeah, 3x squared, so let's just set everything less than or equal to 0. Well, we bring over the 5, that would be a negative 4 less than or equal to 0. Good. Now all we need to do is to factorize the left hand side in order to find the roots, so that we can sketch the graph. So let's see, it's 3 times 4, negative 12. Okay, so the factors of negative 12 that we would use to get a positive 4 would be 6 and negative 2. So 3x squared plus 6x minus 2x minus 4. Okay, so we'll factor out the 3x, and that goes into x, plus 2 minus 2 into x plus 2. therefore we have that. Right, so now that we have factorized this expression, let's solve for x. So we're going to just set three x minus 2 bracket x plus 2 equal to 0 in order to find the critical points, the roots. Now we would have x is equal to 2/3 or -2. Good, so let's sketch our curve here. Now our x values, x equal -2, x equal 2/3. These values are where the graph cuts the x-axis, and since the a term is positive here, the x squared coefficient is positive, so it's going to shape upwards like that. And that's a -4 there, so it would look something like this, right? Good, and we are solving for when 3x squared plus 4x minus 4 is less than or equal to 0. Now this function is less than or equal to 0 below the x-axis because all y values below the x-axis are negative, and if it says less than 0, that means negative. Less than or equal to 0, that means also along the x-axis, because the y values along the x-axis are all 0 along the x-axis. So therefore the x values that fall in this interval would be your solution, including your -2 and the positive 2/3, because at -2 and positive 2/3 the function is equal to 0. So therefore those are possible solutions, and between -2 and positive 2/3 the function is negative, or the graph is negative, the curve is negative, however you want to say it, it's negative. So that satisfies this here, so therefore we can see x, and this is how we would write the solution, x is greater than or equal to -2, less than or equal to 2/3. Right, so this would be our solution. And now for the next problem, should be simpler. Hope you understood this graphical method. Okay. Oh, the other one is a question that involves modulus. Good, now this is a simple problem. You can solve this by either squaring both sides or by simply, which this is way simpler. You can say that, okay, normally with modulus, what's inside the modulus can either be negative or positive, but it will always output a positive value, meaning the modulus of -1 is equal to a +1. The modulus of a +1 is equal to 1. So what we can say then is this x plus 2 can either be a negative value, so it can be negative, or the x plus 2 can be positive. So it can be an instance where you have a negative outside there, or an instance where it's just positive. So we would solve for x in both cases to get the two possible values for x. Right, so from here we'll have x, look at x plus 2 is equal to -3x minus 5, which means if we collect the like terms, we'll have 4x is equal to -7. Therefore x is equal to -7/4, and from here we can say that if we bring the like terms on one side, 2x is equal to -3. This, we bring the x over here, we get 2x, bring this 5 over, that's 2 minus 5, so that's -3. Therefore x is equal to -3/2. So therefore x is either -3/2 or -7/4. We could also do this by squaring both sides. That might be better for some people, because if being that this can either be a negative or a positive, then if we square both sides it doesn't matter, because if you square a negative number you get a positive number, and if you square a positive number you still get a positive number. So squaring both sides and solving for x would still give you the solution. Right, so if we square the left side, we would get x squared plus 4x plus 4 equal to 9x squared plus 30x plus 25. Okay. Good. Now we collect like terms. Well, not collect like terms. Set everything equal to 0. So we just bring everything on one side. That is, therefore we would have 8x squared. If we bring the left side over to the right side, we have 8x squared plus 26x plus 21. And in this case, since these numbers are rather large, I'd prefer to use the quadratic formula to solve this. So therefore we would say that x is equal to minus b, but b is 26, plus or minus the square root of b squared minus 4a Good. So therefore, and it's all over 2a. Therefore x is equal to, let's work out what's under the root sign. Okay, so we have the square root of 26 squared minus 4 times 8 times 21. And that's 2 actually, so that's negative 26 plus or minus 2 all over 16. So therefore x is equal to negative 26 minus 2 over 16, or x is equal to negative 26 plus 2 over 16. So here we would have negative 28 over 16, and here we would have negative 24 over 16. Okay, good. So you can simplify that on your own and check the answer. And I'll end the video here. See you in the next video. Please like, comment, share, subscribe, share with your friends, because they will benefit. I'll see you in the next video.